about orbits and eccentricity. Now, Kepler's first law of planetary motion, published in 1609, states that the path of a planet's orbit is an ellipse with the sun at one of the foci. Asteroids, comets, and other bodies that orbit the sun follow elliptical paths. The closest point to the sun in such orbit is the perihelion, and the farthest point is the aphelion. The shape of an ellipse is related to its eccentricity. So what they're saying then is the semi-major axis A is your aphelion distance. Your semi-minor axis is your aphelion distance minus the distance to the foci is going to be your perihelion distance. We'll get into that in a little bit. So the definition of eccentricity. The eccentricity of an ellipse is E equals C over A. And since we know that C is really equal to the square root of A squared minus B squared, we can switch that to put that over A, where A is a semi-major axis, B is a semi-minor, and C is the distance from the center to either of the foci. Now, the noun eccentricity comes from the adjective eccentric, which means off-center. Mathematically, eccentricity is the ratio of C to A. The larger C is compared to A, the more off-center the foci is. Now, in any ellipse, C is going to be greater than A, C is going to be less than A, but greater than or equal to 0, which means the eccentricity of an ellipse is always going to be between 0 and 1. Now, ellipses highly off-center foci are elongated and have eccentricities close to 1. For example, Halley's Comet has an eccentricity of 0.97. Ellipses with foci near the center are almost circular and have eccentricities close to 0. So really, if you look at Venus's orbit, that's really close to a circle. So that's close to 0. Now, what happens when the eccentricity is equal to 0? So in an ellipse, because A is positive, that means that eccentricity is 0. That means that C is 0, thus A is equal to B. So that means the ellipse degenerates into a circle. So that means that the eccentricity is 0. That means it's going to be a circle. Now, because the ellipse is a circle when A is equal to B, it's customary to denote the common value as R and call the radius of the circle. So when A equals B in an ellipse, it will be a circle. Now, surprising things happen when an ellipse is nearly but not quite a circle as in the orbit of our planet, Earth. So, if we look at example 5, Earth's orbit has a semi-major axis A of 149.598 gigameters and an eccentricity of 0.0167. Calculate and interpret B and C. Well, since E is equal to C over A, that means my eccentricity is 0.0167. That's equal to C over 149.598. That will tell you that if we take 0.0167 times 149.598, we'll get a C value of 2.498. Now, since that's the case, we know that since since A squared is equal to B squared plus C squared, that means B will equal the square root of A squared minus C squared. So a little bit more calculator work will show the square root of 149.598 squared minus 2.498 squared gives us our answer of 149.577. And then again is in gigameters. So that tells you then my aphelion distance again, your aphelion distance is going to be A plus C. That'll be 149.598 plus 2.498. 152.096. That's in gigameters. Your perihelion distance, which is your closest distance to the sun, will be 149.598 minus 2.498, 147.100. Gigameters. Now, the Earth's orbit is going to be nearly a perfect circle. Because A is almost equal to B. Now, the moon's apogee, the farthest distance from Earth, is 252,710 miles. And the perigee, which is the closest distance to Earth, is 221,463 miles. Assuming the moon's orbit of Earth is elliptical with Earth at one focus, calculate A, B, C, and E. Well, here's what we know. We know that the farthest distance from Earth is 252,000. So that means then that my major axis will be 252,710 plus 221,463. We're going to divide that by 2 to find our A value. So our A value is 237,086.5. Okay, so there's our A value. Now, we know that A plus C or A minus C will equal basically our perihelion distance, so the perigee. So that's going to be 221,463. So since we know that then, we know that A plus C doing some little mathematics here, we subtract the 221,000 and add C to both sides. That means 237. So our answer here minus 221,463 will be our C value. So it'll be 15,623.5. Now again, since A squared plus A squared is equal to B squared plus C squared for any ellipse, that means B will equal the square root of A squared minus C squared. So that means B will be 236,571. Now, to find your eccentricity, remember, E is equal to C over A. So we'll take the 15,623.5 divided by your A value. You get an answer of 0.0659. Now, what does all this mean? So our A value, again, is our semi-major axis. Our B value will be our semi-minor axis. Because they're really only about 1,000 miles off, that means it's pretty close to a circle. C is the distance from the center to the Earth, so the center of the orbit to the Earth. And your eccentricity, the closer it is to 0, means it's almost a circle. So the moon's orbit is nearly a circle. Because A and B are almost equal. But it's still an ellipse.